problems relating to electronic configuration of elements. Don't forget, we said the second method or form is orbital electronic configuration in the form of SPDF. Now, when we are talking about orbital is a volume of space where there is a probability of finding an electron, and when we are making use of the second form, which is the SPDF, we want to take note that the number of electrons will first of all enter the orbital that has the lowest energy level, or the lowest quantum energy, the lowest quantum level, and followed by the next. So from that explanation, SPDF, which means the quantum level of this orbital S is lower than that of P. P is also lower than that of D, while F has the highest quantum level. Please take note of that. So when we are filling these orbitals with electrons, we want to start from the orbital that has the lowest quantum level, and we say that is S, P, D, F. But before then, what is the meaning of S, P, and D, F? Simply put, let me just give us the meaning. S stands for sharp, P stands for principal, D stands for diffuse, and F stands for fundamental. For the chemistry students, when you come across these alphabets, SPDF, these are the meaning. Now we want to make use of this method to solve problems on electronic configuration. We want to please take note of the order of energies of the orbitals. We want to take note of this. What does that mean? It simply means that when we want to feed the SPDF with the electron, we want to start with the lowest orbital, the orbital that has the lowest quantum energy, which is 1s, followed by 2s, followed by 2p, followed by 3s, 3p. That is how we follow it sequentially. You cannot start with 1s, then thereafter you want to put 6f as the next orbital. It's totally wrong. So you follow this order of energies, starting from the 1s continually until you get to 7f, depending on the elements that you are given. Then apart from that, we also need to know, just like the shell method, the first method that we explained, we equally need to know the maximum number of electrons that can enter each of these orbitals, the S, P, D, F. Please take note of this as well. The maximum number of electrons that can enter the S orbital is 2 electrons. While for the principal, which is P orbital, the maximum number of electrons that can enter it is 6 electrons. While for the diffuse, which is the D, is 10 electrons. And finally, for the fundamental, which is the F, is 14 electrons. So we are equally going to make use of this principle to solve the problem or any problem relating to electronic configuration. Please take note as we are going to use this method to solve the problem that we'll consider very soon. So now let's go back to this question. What is the electronic configuration of sodium? This was the example we did earlier, but take note, the method we used in solving this problem was the first method, which is the shell method, that is the structure of the atom. Now, we want to see how we can make use of the orbital electronic configuration in the form of SPDF to solve this problem. Following this order of energies as well as the maximum number of electrons that can enter each of the orbitals. Take note, anywhere you see S, have it in mind that the maximum number of electrons that can enter that orbital is 2. Like for example, look at this case, you are seeing 1s. S is there. Provided S is there, the maximum number of electrons that can enter this orbital is 2. The next orbital is 2s. You are equally seeing S, which means the maximum is equally 2 electrons. Then when you move to the next orbital, you are seeing P, which is the principal. And we said the maximum number of electrons that can enter the P orbital is what? Is 6 electrons. So anywhere you see each of these alphabets, you remember this principle. Now let's see how we are going to use this to solve this problem. Now we are going back to the question. What is the electronic configuration of sodium? I want to make use of the second method, which is the use of SPDF. Now, sodium has atomic number of 11. Sodium has atomic number of 11. Now let's start with the first orbital. The first orbital here is 1s. 1s. And we said the maximum number of electrons that can enter the s orbital is what? 2 electrons. So you are going to put it like this. 1s2. And the next orbital after the 1s is what? Is 2s. So you are going to fix that as well. 2s. Because it has the sharp, which is s, we are equally going to put the number of electrons for the s orbital, which is equally what? 2. After the 2s, the next orbital is what? 2p. 2p. And we said the maximum number of electrons that can enter the p orbital, that is the principal orbital, is what? 6 electrons. So which means you are going to fix the number of electrons here. Now, how do we know if this is correct? What do we do? You know, we said all these numbers that you are seeing, 2, 2, 6, they are the number of electrons that enters each of the orbitals. So what you just simply do is you sum this number of electrons together. 2 plus 2 is 4. 4 plus 6 is 10. It's not yet up to 11. So what do we do next? What we do next is we proceed. After the 2p orbital, move to the next orbital, which is 3s. So which means you are going to put 3. Let me just fix it here because there's no space here. 3s. Now we said the maximum number of electrons that can enter the s orbital is 2 electrons. But in this case, we have 2 plus 2, 4. 4 plus 6 is 10. And we need, how many number of electrons do we need to add to this that will give us 11? Is 1. So which means in that case, we are not going to put 2 here. It's going to be 1 electron. So in this case, our answer to this is 1s2, 2s2, 2p6, 3s1. So this is our answer to this question. Now we want to consider another example. Question to example 2 says, what is the orbital configuration of calcium? As a chemistry student, you are supposed to know what element is this, and you are supposed to know the atomic number. But before we put an answer to this question, please take note. In our previous example, in that example 1, you know the question we made use of, what is the electronic configuration of sodium? But in this very particular question, it says, what is the orbital configuration? This is the one I want to explain. Please take note. When you see a question like this that they made use of the word orbital configuration or electronic configuration, or in some case they will make use of what is the electron configuration, they are still the same thing. So please take note of that. Now we want to see the orbital configuration of cation. The atomic number of cation is 20. And let's see how we are going to use the order of energies of the orbitals to get the orbital or electronic or electron configuration of cation. Now we are starting with the first orbital, which is what? 1s. We are starting with 1s. So it will become 1s2, that is the maximum number of electrons that can enter that. The next orbital is 2s. Because s is there, it's still going to be 2 electrons. After the 2s orbital, we proceed to the next orbital, which is 2p. And we said the maximum number of electrons that can enter the p orbital is what? 6 electrons. So which means our 2p will have 6. Now when we start summing the electrons, 2 plus 2 is 4. 4 plus 6 is 10. And we said the atomic number of cation is 20. So which means we need 10 more electrons. Now after the 2p orbital, the next orbital that we have is the 3s. And we said for the s orbital, the maximum electron is 2. The next orbital is 3p. The maximum number of electrons is 6. Now let's quickly sum the electrons. 2 plus 2 is 4, 10, 12, 18. So which means 2 is remaining. After the 3p orbital, the next orbital is what? 4s. So because it is 2 that is remaining, this will now become 4s2. So therefore, the electronic or orbital configuration of cation is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So that is the answer to that. Please always take note. Any element you are given, the first thing you will do is to fix the atomic number of the element. When you follow this process, I think you will not have any problem that when it comes to electronic configuration. Okay, now I want to consider example 3. Please take note of this question in example 3. What element has this electronic configuration? They have given us the electronic configuration. Now they are asking us what element has this electronic configuration. The element that has this electron configuration. You know, previously I said when they make use of the word electron or electronic or orbital, they are still the same thing. They are just using that to confuse the students. Now they have given us the electron configuration. Now how do we know which element possess this electron configuration? What you simply do is just sum the number of electrons, sum them together. This is 2 plus 2 is 4, 4 plus 6 is 10, 10 plus 2 is 12, 12 plus 2 is 14. In that case, you now ask yourself, what element has the atomic number 14? So that is where you now need to think. So simply put, the element that has this electronic configuration is silicon. Silicon has atomic number 14. So simply put, this is our answer, which is silicon. Thank you very much for joining us in this channel. We appreciate you, and we also advise you to please continue joining us, because in this channel we have a lot of topics in chemistry that we'll be covering, both practical aspects of chemistry. We also advise you to please tell your friends, your family members, if possible, tell people that are not your friends, that are interested in becoming gurus in chemistry. Thank you so much for your time, and do have a lovely day.